Hey guys, how's it going? Just a quick video here. I'm going to explain problem 6 from the review sheet. It's got 3 parts, A, B, and C. We're going to take a look at all 3 parts. Talk to me tomorrow too, and I can do some other problems from the review sheet, whichever ones you guys want to see explained in a little bit more detail than just an answer key. Okay, so the key on this problem, this is a very important problem because what we have is a changing triangle here, but parts of the triangle are changing, parts of the triangle are unchanging. The setup is the whole key here. If you set this up wrong, it's going to lead to disaster on all 3 parts. Okay, so here's the scenario. A 10-foot ladder is leaning against a house. The ladder begins to slide down the side of the house. The base of the ladder is sliding away from the house at a rate of 3 feet per second. How fast is the ladder sliding down the side of the house at the instant the base of the ladder is 6 feet from the house? Okay, so there's a lot going on here, but there's a couple things we need to understand here. This ladder is 10 feet, and it will always be 10 feet throughout the entire problem. Please, in your picture, right, you can just use you can just annotate the picture that's provided. Okay? Or if you draw your own, whatever you do, call that 10 and never give it a letter. Okay, I'm just going to annotate that as 10. I'm not going to call it L because I'm only giving letters here to things that are varying throughout this problem. And it's not varying. It's going to be 10 feet the whole time. However, the base of this triangle and the height of this triangle will be changing throughout this problem. So it's a really important skill to be able to identify what's staying constant and what's varying. In our picture, it's really important that we annotate the picture with numbers for things that are constant and variables for things that are varying. Even if we know what one of those variables is at a certain instant, resist the urge to put 6 at the bottom of that triangle there. I'm going to call it a variable. I'm going to choose the variable x for my base and y for my height. Now, when you solved this problem, maybe you used b for the base and h for the height, or maybe you used a for the base and b for the height, or whatever. It doesn't matter what you use. What's important is that you assign that picture with letters. Because we use our picture here, we're going to write several equations. It's important to remember what is constant and what is varying. Okay, so 10 never shows up in my no column. Okay, but I want to start making a no column here for part A. Okay, so again, I see when I reread the problem here, I see a 10-foot ladder is leaning against a house. That's constant, so I don't need to add it to my no column. But the next part I do. The ladder begins to slide down the side of the house. The base of the ladder is sliding away from the house at 3 feet per second. So the base of the ladder I know is the bottom of the ladder. That is moving away from the house at 3 feet per second. 3 feet per second is clearly a rate. Okay? So this is the rate of change then of what part of the triangle? Will be the part of the triangle that I called x in my picture. So I know dx dt is going to be related to this 3. But I want to do just a little bit of analysis here to understand, will this be a positive 3 or a negative 3? Well, as that ladder is sliding down, that side of the triangle x is going to be getting bigger. Therefore, dx dt equals positive 3. The next part A here says, how fast is the ladder sliding down the house at the instant? So how fast is the ladder sliding down the house? I want to know how fast, right, this top of the ladder is coming down. Well, I can determine that by how fast y is changing, right? The top of the ladder is going to tie to y here, whereas the base of the ladder ties to x. So what I need then is dy dt. Again, it says at the instant, the base of the ladder is 6 feet from the house. Okay, 6 feet is not a rate. So that tells me that that base x is equal to 6 at this instant. So I'm going to add that to my no column. And again, just to be clear, that 6 there should be equal to x in your no column. The 6 should not show up in this picture. Okay? Because it'll mess us up when we write our equations later on. Okay, the other thing I'm going to do right now, and any of these right triangle problems, I know the instant x is 6, the ladder is 10, because the ladder is always 10. But if it might help to figure out what y is, right? Well, 6 and 10, I notice, are both divisible by 2. When I divide them both by 2, I see 3 and 5. So I'm thinking this is a 3, 4, 5 triangle. So the side that's missing is the 4 side, so I got to double that to get y equals 8. For a 6, 8, 10 triangle. If you don't see it that way, right, you can just solve the Pythagorean theorem and do 100 minus 36, and you'll get 64. The square root of 64 is 8. Okay, now I'm ready to go ahead and write an equation. The equation that relates these three is the Pythagorean theorem. But I'm not going to do a squared plus b squared equals c squared, because a and b and c aren't variables that I have in this problem. So I'm going to write x squared plus y squared equals 10 squared. Now I'm ready to do the derivative. So when I do this derivative, I just remember I'm always tacking on d whatever the variable is dt when I do the derivative of a variable. So the derivative of x squared I know is 2x. I got to tack on the x dt. Plus 2y dy dt equals 0. Remember, the derivative of a constant is always equal to 0. First thing I'm going to do here is divide both sides of the equation by 2. So it's going to cancel out the two 2's on the left. 0 divided by 2 stays 0. I'm going to plug in everything and solve. So x is 6, dx dt is 3, plus y is 8, dy dt is what I need. So I'm going to go ahead and solve this. I'm going to get 18 plus 8 dy dt equals 0. I'm going to subtract the 18 over. I have 8 dy dt equals negative 18. So dy dt equals negative 18 over 8. Both of those divide by 2, so it's negative 9 over 4. My unit here would be feet per second. Because y would be measured in feet, t would be measured in seconds. The other thing I like to do is add that then to my no column, because this problem continues. So I don't want to lose track of that negative 9/4. It should make sense that dy dt is a negative number. Okay, and again, so that means, right, y is shrinking at negative 9/4 feet per second. So that means the ladder is sliding down at 9/4 feet per second. Okay, B says, at that instant, what is the rate of change of the area of the triangle that's formed between the ladder, the house, and the ground? So I got to know my area of a triangle formula. So I know the area of a triangle is half base times height. So here's what I'm going to do. I don't know why this thing is kind of spazzing out on me. There we go. All my no column can just come down. I don't need to rewrite it. What I need now is the derivative of the area of the triangle with respect to time. Now, a lot of people know the area of a triangle is base times height over 2, but people get confused doing that derivative. So I want you to get in the habit of writing area equals half base times height. It's more obviously than a product rule to solve. Okay, so I'm ready to do my derivative. I'm going to do dA dt equals. This is my first term, this is my second. So I do the derivative of the first. The derivative of half b is half. And I kind of tack on my dB dt. That's the derivative of the first times the second, plus the first times the derivative of the second. I can go ahead and plug in and solve this thing. So I'm going to have half dB dt was 3. H, oh my goodness. You see the problem I did here? Oh, good learning opportunity. I used half BH here when I should have been using half X and Y, because I wrote an equation. So let's go ahead and erase that. I introduced B and H, and I haven't been using B and H. Should be using half X and Y. Right? So you might make a mistake like that. I'll pretend like that was an intentional mistake, even though it wasn't. My derivative then, I'm still doing my product rule. It's going to be half dx dt y plus half x dy dt. Now it makes more sense plugging in. So dA dt is going to be half. Dx dt was 3. Y was 8. Plus half of x, which was 6, times dy dt, which is negative 9 over 4. Now, when I multiply these by hand, I'm going to multiply these two first because half of 8 is really easy to do. Half of 8 is 4. 4 times 3 is 12. So I'm going to get dA dt equals 12. This is now going to be a negative number. Half of 6 is 3. 3 times negative 9 fourths would be 27 fourths. Now I just need to subtract these fractions. I need a common denominator, so times 4 times 4. I'm just over here, I'm going to figure out what 48, because that's 12 times 4 minus 27 is. I get 21. So my answer is 21 over 4. My unit then would be, it's an area, so it'd be square feet per second. Okay. Good. Okay, the last thing here. At that instant, what is the rate of change of the angle theta? Okay. Again, here's my sketch. I've got 10, y, and x. Theta is between the base of the ladder and the ground. So theta would be down here. So what I need is d theta dt. For an equation, I can write any of the trig equations. I usually avoid tangent because I don't like secant squared theta as a derivative. So I think I can't remember what I did on the key. I'll use sine theta for this one. So my equation then is going to be sine theta equals opposite, which is y, over hypotenuse, which is 10. But again, I prefer to do that derivative as a power rule. So I like thinking of this as sine theta equals 1/10 y. Okay, now I'm ready to do the derivative. The derivative of sine theta we know is cos theta. But don't forget to tack on your d theta dt. Equals, the derivative of 1/10 y is very simple. It's just 1/10. But then I got to tack on dy dt. Okay, now I can plug in and I can use numbers for everything. Cosine theta then would be x over 10, and x we have been using as 6. So it's 6 over 10. Again, remember your SOHCAHTOA. Cosine is adjacent over hypotenuse, so this would be the adjacent. This would be the hypotenuse, but I can use 6 for x now. d theta dt equals 1 over 10 times dy dt, which was negative 9/4. Okay, I'm going to simplify this a little bit. 6 over 10 d theta dt equals negative 9 over 40. And then to get rid of 6/10, instead of thinking of it as dividing by 6/10, think of it as multiplying by 10/6. It's cancel. Multiply by 10/6. And again, to make life easier for you, do some cross-canceling here. 10 and 40 are both divisible by 10, so that's going to be a 1, that's going to be a 4. 9 and 6 are both divisible by 3, this is going to be a 2. Negative 9 divided by 3 is negative 3. Don't lose track of this negative right here when you do that. And we get d theta dt to equal negative 3 times 1 is negative 3 over 4 times 2 is 8 radians per second. And we're done. So you got to see me make a pretty big mistake there. But hey, that's okay. People make mistakes. It's important we can catch them and move on from there. That's it for today. See you guys tomorrow. 2 trains, bye.